The question, are we alone, is one that has been asked since the very beginning of science. As our old ancestors gazed into the night sky and believed that the sun and the stars were themselves gods of the heavens, we as a human race have always pondered the question of our existence. Are we unique in this universe, or are we just one of millions of other advanced races in the universe, all searching for one another? It wasn't until the 19th and 20th century, however, that we are now able to put these questions under scientific observation. We are now empirically testing these hypotheses of the possible existence of other ET races in not only the universe, but our own Milky Way, as we have advanced into the age of super advanced telescopes and satellites, super sensitive to every type of frequency and light spectra. Using our combined knowledge of everything from astronomy to biology, to physics to meteorology, scientists now are combining their skills into a new and intensely complicated projects in the hopes to discover another alien race. Although we are only now beginning to search for alien life with extremely elaborate scientific experiments and empirical observations, the search for life in the universe started long ago.
Historians believe that many cultures have been searching for extraterrestrial life since the ancient times of the Egyptians, Arabians, and Chinese. They considered extraterrestrial life supernatural, making it confusing for historians to analyze and to decipher between the ideas of aliens and the afterlife. The ancient Greeks spent a lot of time contemplating the idea that there is intelligent life outside of Earth. The first known Greek to contemplate life in the universe was a Greek philosopher-writer named Thales, who lived around 600 BC. He thought it was very possible that life existed on the moon and the sun. We now know that this is wrong, but he opened up a lot of doors for other philosophers to start thinking about extraterrestrial life. After Copernicus proved that the sun didn't revolve around the Earth, the view on extraterrestrial life started to change too. One man named Giordano Bruno proposed that every star has a solar system like ours. The Catholic Church didn't approve of this, and he was burnt at the stake for proposing such an idea. Many other philosophers thought that life could still possibly exist in our solar system. Many thought Venus, Mars, and Jupiter were all planets that could support life. They thought that extraterrestrial life must look completely different from life on Earth because of the different conditions on these various planets. The idea of a hybrid between a reptile and a human was a very common image for aliens, and this idea carried on to the beginning of the 20th century and is still considered among many UFO enthusiasts today. Although many of these planets were originally thought to possibly hold life, we now know that the environments like Jupiter's and Venus's atmosphere cannot sustain living, intelligent life. This brings up many questions, however, of how exactly our planet is different from the others, and how our little blue speck in our universe is extremely unique in its ability to harbor life.
It is difficult to say what is necessary for life to survive because most of our information is based on assumptions. We know what is needed for life to survive on Earth, so it is a mystery if life could survive in surroundings that are drastically different to ours on other planets. To understand what is necessary for life to survive, it is important to clearly define what life is. One definition says, living systems are capable of metabolism, growth, reaction to stimuli, reproduction, mutation, and reproduction of its mutation. Another says life is the quality that distinguishes a vital functioning being from a dead body, but isn't clear what that quality might be. On Earth, life forms have an orderly, complex structure that is based on carbon molecules. Life requires energy either directly through photosynthesis or indirectly by gaining energy stored in materials. All forms of life on Earth have to be able to stabilize their internal conditions such as temperature, water levels, and salt levels. They have a constant metabolism and are able to respond to stimuli and adapt to their surroundings. Living organisms on Earth also change and grow larger throughout their lifespans. Here on Earth, the majority of life requires oxygen, water, a source of nutrients and energy, and appropriate physical conditions to live. On Earth, the biosphere allows us to survive by trapping the heat we need from the sun, but also by protecting us from UV rays. Our atmosphere also has all the gases we need to survive, which include hydrogen gas, ammonia, water, methane, oxygen, and nitrogen. The amino acids that formed when the Earth was still young are vital for the emergence of living organisms. Amino acids are the building blocks for nucleic RNA and DNA, which carry all the genetic information for organisms. Amino acids led to the development of proteins, which then led to the development of the cell. There have been organisms found in extreme conditions on this Earth. Bacteria have been found in the Earth's crust, and algae has been found in deep water vents that are 169 degrees Celsius. Normally, water would boil at this temperature, but the immense pressure prevents this from occurring. Possible life forms have also been found on meteorites where there was no trace of water. These facts prove that it is definitely difficult to put standards on what is necessary to sustain life. All we know is what the organisms on Earth need to survive, so until we find life on other planets, we have to keep to our assumptions.
A good start, however, in the search for understanding how life is made on other planets, as well as the search for life itself, is by analyzing our closest neighboring planets, Venus and Mars. Many scientists believe that there is a strong possibility that life has existed on one or both of these planets in the past. It is possible that there is microbial life on either one of the planets. So when searching for life in other solar systems, it's helpful to examine the reason why these two planets are now virtually uninhabitable. To start, let us take a look at Venus. The consensus among scientists is that Venus once had a climate very similar to Earth, with plenty of water and oceans.
Unfortunately, somewhere along its 4 billion year timeline, Venus underwent a catastrophic climate change that gave it the environment it has today. The planet experienced a greenhouse effect similar to what is happening on Earth today, but much more extreme, where very large amounts of carbon dioxide got trapped in its thick atmosphere. However, because Venus is closer to the Sun than Earth, the effect was magnified. Scientists called it a runaway greenhouse effect, and it has brought the temperature on Venus up to 400 degrees Celsius. Unlike Earth, Venus lacks a magnetic shield, which causes it to feel the effects of solar wind and cosmic radiation. With that and the extreme temperature rise caused by the runaway greenhouse effect, all of the water was virtually eliminated from Venus, and now it is highly unlikely that there is any life on Venus with its extreme climate. As for Mars, the reasons for life are opposite of those for Venus. Like Venus, it is widely accepted that Mars had an abundant supply of water in the past because of the channels and canyons that seem to have been formed by running water. However, there is no evidence of liquid water on the surface of Mars nowadays. The reason for this is not known, but a common theory is Mars used to have a much thicker atmosphere and warmer climate. Over time, however, the atmosphere thinned out as the carbon dioxide supply was not replenished. Eventually, the atmosphere became too thin to support liquid water, and Mars became the cold, dry planet that it is today.
Conclusively, the reason most supported today that both planets failed to support life is that both of their atmospheres were unable to regulate themselves. Their respective distances from the Sun didn't help either, as this had a dramatic effect on their climate, causing them to lose their liquid water supplies, which to our best assumptions appears to be absolutely necessary for life. With this information on how life is formed, as well as mankind's constant search for knowledge and the truth to our place in this universe, it was no surprise that SETI would eventually be born.